All right, let's dive into another chemistry question. This one says balance the following redox reaction. And we've got this reaction below. So we're just trying to balance the reaction. We're just trying to put coefficients on each of these compounds to make the same number of elements on the left as we have on the right. So let's list out our elements here. We've got nitrogen, hydrogen, and oxygen on the left side. We've got the same elements on the right side, which is how it has to go. So thankfully that's the case. Let's just see how many we have on each side. So we only have one nitrogen on the left side. We've got 3 hydrogens and 2 oxygens before we put any coefficients in front of these. And on the right side, we've got 1 nitrogen, which is good because that's balanced. Then we only have 2 hydrogens, and then we got 1 oxygen in both compounds, which means we have 2 oxygens. So oxygens are balanced, nitrogens are balanced, but unfortunately, hydrogens are not. And in order to balance the hydrogens, we've got a 3 and a 2. We have to find the lowest common multiple, which for these two numbers is 6. So the lowest number I can make these hydrogens by multiplying is 6 on both sides. And the way that I would do that is by multiplying the 3 hydrogens on the left by 2. So I put a 2 coefficient out front here. And I have to multiply the right side by 3. What that's going to do is end up giving us 6 hydrogens on both sides. You can see that I have 2 of this NH3 now, which gives me 6 hydrogens. And I've got 2 of the H2Os, which gives me 6 hydrogens on the right side. But that also affected other elements, right? There's nitrogen involved in this compound as well. So now the nitrogens, we've got 2 nitrogens on the left side because 2 times 1 is 2. And then on the right side, the nitrogens weren't affected, but the oxygens were. I'm tripling the number of oxygens in the H2O, and then we still got 1 more here. So the total number of oxygens now on the right side of the equation is 4. So now everything's out of whack because we tried to fix the hydrogen problem. Now we have to try to balance other stuff. So nitrogens aren't balanced. I need, we've got 2 on the left. I need 2 on the right as well if I can do that. And I can put a 2 out front here. It's going to fix our nitrogen problem. But that also affected our oxygens, right? So we added another oxygen by multiplying this oxygen by 2. So now we've got 3 from the H2O, 2 from the nitrous oxide, and we've got 5 total. So now we've got a new problem. We've got 2 oxygens on the left, 5 oxygens on the right. So we're going to have to use lowest common multiple again. So unfortunately, 2 doesn't multiply into 5. So I can't just, this isn't an easy fix, unfortunately. I could do 2.5 here. 2.5 times 2 will give me the correct number of oxygens. But 2.5 isn't a coefficient that we're allowed to use. We can't have a half of a molecule. So, I mean, ideally, I could put a 2.5 out here, but we're not allowed to do that. So we got to make this a whole number. And since we have all the right ratios now, I can just multiply everything by 2. So if I just multiply this whole thing by 2, we should be balanced. And that's going to give me 4 NH3 plus 5 O2 goes to 4 NO plus 6 H2O. And that's our balanced equation right there.